morning, boys and girls. Welcome to week 3, day 5 of Cumberland at Home. I'm Mrs. Driggers, and I am so excited to work with you today on math. Today is our last day of Cumberland at Home Summer Edition. I am excited to show you 3 different activities that you and your family can do at home. Today, we will be working with our 100 board. We will be demonstrating our understanding of place value to work on rounding to the nearest 10, identifying odd and even numbers, and adding 2-digit numbers together. Are you ready? Let's get started. Today, we are going to use our hundreds chart to review place value. Remember, a hundreds chart or hundreds board is a graphic organizer for the numbers 1 through 100. Today, we are going to look at some activities that will apply our knowledge of digits to help us recognize their place value. So remember, a digit is any form of the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now these digits sit in what's called a place. For example, if you look at the number 104, the digit 4 is in the ones place, the digit 0 is in the tens place, and the digit 1 is in the hundreds place. Let's begin with round to the nearest 10. In this activity, you are going to need your hundreds board, and you're going to need a counter. So Mrs. Driggers is going to use a penny. In addition to your hundreds board and counter, you're going to need the individual tiles that were cut out from last week's activity. Count with me by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If we looked at our tens, notice there are 2 digits. There's a 1 and a 0, 2 and a 0, 3 and a 0, and so on. These digits sit in a certain place value. The 0 digit sits in what's called our ones place value. This is showing us how many single units are in this number. There are no single units in any of our tens. That's why the digit 0 is holding that place value. Then the digits 1, 2, 3, 4, 5, and so on are sitting in what's called the tens place value. That's showing that there is a group of tens. So in the number 10, there is 1 10. In the number 20, there is 2 tens. In the number 30, there are 3 tens. So when we're rounding numbers to the nearest 10, we have to look at the ones place value. Okay, so for example, if I called out the number 14, I'm going to place my counter on the number 14. When you round, you can either round down to 10 or up to 20. It's important that you look at the ones place value when deciding to round down or round up. So think about it like this. If you're looking in the ones place value starting at 10 to 20. Let's count them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the pattern starts over again for the digit in the ones place value, right? It starts over with 0, 1, 2, 3, and so on. When you're deciding if you have to round down, meaning if I'm at 14, I would round down to 10, or I would round up to 20, and I look at my digit in the ones place value, the digits 0, 1, 2, 3, 4, any digit in the ones place value that's either a 0, a 1, 2, 3, or 4 is going to get rounded down. Okay, so 14 is closer or to the number 10. So if I were to round down, I'm rounding down to 10. Digits in the ones place value that are 5, 6, 7, 8, or 9 will get rounded up to the next 10. So for example, if I wasn't on 14, say I was on 16, I would look at that ones place value and see that it is a 6. And because 6, the digit 6 falls within the 5, 6, 7, 8, or 9, I'm going to round 16 to 20. It's closer to the 20, that's the nearest 10, than it is to 10. Let's start this activity. If you're working at home, you can work with a parent, a sibling, or another adult, or even just yourself. But if you're working with a partner, you want your partner to pull out one of the number tiles from your bag. They will read that number out loud, 77. You would then take your counter and place it on the number 77. Okay, this is where now we have to decide, and we're rounding our digit, or excuse me, we're rounding our number based off of the digit in the ones place value. So let's take a look at 77. And I've put a reminder card at the top of our hundreds board, okay? If you notice 0, 1, 2, 3, 4, you're going to round down to the tens, the nearest 10. And if you have a digit in the ones place value 5, 6, 7, 8, or 9, you're going to round up to the nearest 10. So let's look at 77. 77 is in between which two tens? It's in between 70 and 80. So when I look at 77, I'm looking at the digit in the ones place value. The digit in the ones place value in the number 77 is 7. 7 falls within 5, 6, 7, 8, or 9. So I'm going to round up to the nearest 10. So 77, if I were to round it up, is closer to 80. Let's try another one. Six. 6 is a one-digit number, and the nearest 10 would be 10, or it would be 0. So looking at the number 6, is 6, if I were to round it, is it closer to 0 or is it closer to 10? Well, 6 falls within 5, 6, 7, 8, or 9, so I'm going to round up to my nearest 10. So if I were to take the number 6, it would be rounded up to 10. $43. I'll take my counter, put it on 43. 43 falls between 40 and 50. I'm looking at my digit in the ones place value in the number 43. So right now, it's a 3. Looking up here, 0, 1, 2, 3, or 4. Because 3 falls within these 5 digits, I'm going to round down. So 43 is rounded down to 40. It's closer to the 1040 than it is 50. $31. 31. If I look at the number 31, I see that there are 3 10s, 1 1. Am I looking at my tens place value to decide how I round? No, I want to look at my ones place value. Okay, so the digit 1 is in the ones place value. When I look up here, because I see 1 within my first 5 digits, I know I'm going to round down. The 2 10s that 31 falls in between is 30 and 40. So if I were to round 31, is it closer to 30 or is it closer to 40? 31 is rounded down to 30. Okay, so this activity can be continued at home. Remember, this is a great activity for you to continue to practice recognizing your digits sitting in different place values and whether or not that digit in the ones place value would have you round down or round up to the nearest 10. The next activity I want to model for you is called odd or even numerals. Odd numbers are whole numbers that cannot be divided exactly into pairs. They end in 1, 3, 5, 7, and 9. Even numbers are whole numbers that can be divided exactly into pairs. They end in 0, 2, 4, 6, and 8. When we think of even numbers and odd numbers, and they talk about being divided exactly into pairs, I want you to think about socks. Okay? Mrs. Driggers has a pair of socks. How many socks do I have? I have 2 socks. So to have a pair is to be in groups of 2. Okay, so right now my pair of socks are even because there's one pair of 2 socks. Okay, if I were to add a third sock into it, does this sock have a partner? No, it does not. So having 1, 2, 3 socks, 3 is an odd number because my third sock does not have a partner, or it does not make a pair. If I wanted to make this a pair, I would have to add a 4th sock, right? So if you think about it, I have 4, I'm showing you 4 socks. 1, 2, 3, 4. These can be a pair and these can be a pair, right? So there are 2 pairs of socks. So because I have 4 socks, that these would be, 4 would be even, right? There's no odd one out, right? I always think about like the odd man out, right? Everyone has a partner. So let's look at this in numbers. Okay, if you can see, I have the numbers 1 through 10 on my table. I want to model for you how we can see whether or not these numbers are even numbers or odd numbers. Now remember, you're looking for numbers that can be divided exactly into pairs. You don't want any numbers to have an odd man out, or it would be an odd number. So let's start with the number 1. If I were to take 1 penny, this 1 penny, actually I'm going to do dimes, so it might be easier to see. This 1 dime represents the digit or the number 1. Does 1 have a partner? Can it make a pair? No, because it doesn't have another dime to be its partner. So the digit 1 is odd. It cannot be divided exactly into pairs. It only has 1. Let's look at the number 2. How many dimes do you see in the number 2? 1, 2. Do those 2 dimes make a pair? Yes, they do. They are, and so 2 is an even number. All right, let's build 3. If I have 2, I'm going to add 1 more to make 3. Looking at my 3 dimes, because my 3 dimes make and model 3. Can these 3 dimes be divided exactly into pairs? Look for just a second. We have 1 pair up here. Does this dime right here have a partner? No, it does not. This dime, Mrs. Driggers likes to say, is odd man out. Because this partner does not have, or this dime does not have a partner to make a pair, 3 is an odd number. Let's go ahead and build 4. 1, 2, 3, 4. Can 4 be divided into pairs? I can divide my 4 into 1 pair and another pair. So are there any dimes left out? Or do all of my dimes have a partner? They all have a partner. So the number 4, or the digit 4, is even. Okay, 4 dimes can be evenly divided into pairs. There's no dime that is left out without a partner. So let's go ahead and build 6. Or excuse me, let's build 5. 1, 2, 3, 4, 5. If I tried to divide or break apart my 5 into pairs, I could make a pair with these 2 dimes and a pair with these 2 dimes, but this dime is all by itself. It does not have another dime to make a pair. So because this dime is the odd man out and doesn't have a partner, the digit 5 is an odd number. Just like in our activity rounding to the nearest 10, when you're deciding if a number is odd or even, you are looking at the 1's place value. Okay, so if I started with my 1 digit, my single digit numbers, and I used my coins to show you 1, 2, 3, 4, 5, and so on, which digits would be odd or even? So if pennies were my odd and dimes were my even, 1 is odd, 2 is even, odd, even, odd, even, odd, even, odd, even. Are you noticing a pattern? if you were to look at, say, the number 31 through 40, I'm not looking at my tens place value, 3, 3, 3, 3, and so on. I'm looking strictly at that ones place value. So because 31 has 1 in the ones place value, I know that 1 cannot be divided evenly into pairs, so 31 would be odd. What about 32? 32, if I look at the ones place value, the 2 can be divided evenly into pairs, so 32 would be even. Okay, so this is what you're going to do in the odd or even numerals activity. Starting at the number 30 to 50, you want to either cover up 10 odd numbers or 10 even numbers. So if I started at 30 and I wanted to cover up my odd numbers, I might think to myself, okay, the ones place value is 0. I know 0 is an even digit. So if I was covering up the odd numbers, I'm going to look at 31. I know the 2 is an even digit. 33. 3 is an odd digit. 35. 37, right? And start to notice the patterns. What makes 31, 33, 35, 37 an odd number? Can you explain to someone at home how you know those digits are odd? Have fun with this activity, boys and girls. One of the things in math that's really important is being able to articulate or talk about your math thinking, right? So it's really important if you can figure out the patterns in your numbers that show either the odd numbers or the even numbers. Try to explain to someone how you know these are odd numbers or even numbers, or what you're observing when you're covering up odd numbers or even numbers, right? We really want to strengthen that ability to have to be able to share our thinking mathematically. All right. The next activity that Mrs. Driggers is going to model for you is called Hundreds Board Hustle. In this activity, you are going to need your 100 board, 2 pennies, a pencil, and a piece of paper to record on. The object of this activity is to create addition equations by tossing a penny on the board and writing down the number it lands on. Then you will toss a second penny on the board and add that to your first number. You will solve the equation and then repeat the process of tossing the penny onto the board, building 12 different equations. As I begin, I'm going to gently toss my first penny onto my hundreds board. So it landed on 63. And now I'm going to toss my second penny onto the hundreds board. I'm going to slide it down over 7. So I started with 63. So on my piece of paper, I'm going to write 63 plus 7 equals. Now, this week we have been talking about place value. We know that digits in a 2-digit number hold a value depending on what place they sit in. So in the number 63, the digit 3 is in my ones place. This means that there are 3 individual units. The 6 is sitting in the tens place. This means that there are 6 tens. We can represent 6 tens by drawing 10 rods. So how Mrs. Driggers represents 10 rods is by drawing one line down. But as I draw the line, I'm counting by tens. So watch me. 10, 20, 30, 40, 50, 60. Now I'm going to switch over to circles to represent my ones. 61, 62, 63. There's my 63. Now I'm going to move over to the 7, and because 7 is a one-digit number, the 7 is in the ones place value. So I'm going to represent 7 with 7 circles. 1, 2, 3, 4, 5, 6, 7. If I want to add together 63 plus 7, I'm going to start with my tens. I'm going to start with counting by tens and then count on by ones when I get to 63. So watch me as I count and add 63 plus 7. 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. So 63 plus 7 is 70. Now that I have one of my equations completed, I'm going to take my pennies off of my hundredths board and I'm going to repeat the process of tossing the penny onto the hundredths board. $52 and 48. So I'm going to record my new equation. 52 plus 48 equals. So same thing as I did above, I'm going to represent both of my two-digit numbers using a picture, but I'm going to be using tens and ones because it would take me a very long time to sit here and draw 52 circles and 48 circles. So I'm going to represent my numbers using base 10 model of tens and ones. So I'm going to represent 52 by having 5 tens and 2 ones. 10, 20, 30, 40, 50, 51, 52. Now I'm going to represent 48. 48 has 4 tens, 8 ones. So I'm going to draw 4 tens, 10, 20, 30, 40. Now I'm going to switch over to my circles for my ones and add 8 ones. So I have 4, 5, 6, 7, 8. Now, to add 52 plus 48, I'm going to count all of my tens first. That means I'm going to count my 5 tens from 52 and my 4 tens from 48. Then I'll go back and count on my ones in 52 and my 8 ones in 48. So watch me as I model. 10, 20, 30, 40, 50, 60, 70, 80, 90. So I'm at 90, but now I'm going back to, I'm not counting by tens anymore, I'm counting by ones. So I'm at 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. So 52 plus 48 equals 100. Another way to select two numbers from our 100 board to make an equation is you can use your individual number tiles, right? Because Mrs. Driggers could be chasing around her pennies if they don't land a certain way. So I could pull out 2 tiles, 24 and 40. So those were the 2 tiles that I pulled out, and I can record an equation based off of these 2 numbers. Draw a picture of my 24 using base 10. So I'm going to use 10 rods and 1s. So 24 has 2 10s and 4 1s. 10, 20, 21, 22, 23, 24. 40 has 4 10s, 0 1s. So 10, 20, 30, 40. And I'm not drawing any 1s because there's no 1s in my 1's place value. 0 is there to hold the 1's place value. So I'm going to come back to 24 and I'm going to count by 10. I'm going to count my 2 10s in 24 and my 4 10s in 40. Then I need to go back and count my 1s. So let's try together. Count with me by 10s. 10, 20, 30, 40, 50, 60. Now count on from 60 by 1s. 61, 62, 63, 64. 24 plus 40 is 64. Now I have 2 two-digit numbers. I'm going to represent these numbers using 10s and 1s. 34 has 3 10s and 4 1s. So I'm going to represent 34 with 3 10s, 10, 20, 30, and 4 1s. 31, 32, 33, 34. 13 has 1 10, 3 1s. So I'm going to represent 1 10, 3 1s. 1, 2, 3. So 10, 11, 12, 13. To add 34 plus 13, I'm going to start by counting by 10s in 34 and then the 10 in 13, and then go back to count on my 1s in 34 and 1s in 13. So count along with me. 10, 20, 30, 40. Now count on from 40, count on by 1s. 41, 42, 43, 44, 45, 46, 47. 34 plus 13 equals 47. All right, boys and girls, you can continue to pull numbers out of your baggie of number tiles or continue to practice tossing those pennies onto that 100 board and come up with all different kinds of equations. Remember, when adding 2-digit numbers plus a 2-digit number, represent these numbers by drawing tens and ones. And make sure to count all the tens together, add all the tens together first, then go back and count on by ones. Wow, boys and girls, I am so proud of you. Great job. You have worked so hard over the last 3 weeks. I am so proud of how much you have progressed and grown in your math skills. Keep up the hard work and have a great rest of the summer. Bye.